Okay, so key things that we need to remember about the spread of our data and the standard deviations. Okay, so for any normal distribution, these facts apply. Within one standard deviation of the mean, we have 68% of the data, okay, which is this diagram here. So what that's really saying, okay, if that's 68%, that's 0.34, that's 0.34, that section there, all right? Not forgetting that from there to there is 0.5, it's half the data, all right? Within two standard deviations, we have 95% of the data. So what does that mean? That means if that's 95%, means that little section there is 0.025 or 2.5%. That little section there is 0.025. That's 0.475, which is half of 95. 0.475, all right? And so we have to remember these things. Same thing here. For the third one, 3 standard deviations with the mean is basically all of the data. So the only thing that's missing is 0.3%. So either side is 0.015. So just a very small amount is outside of 3 standard deviations of the mean. All right. So to try and make use of that, all right. So whenever we're asked to do something with a normal distribution, we do a diagram. So it doesn't matter how perfect it is, but try and make it roughly. So there's my mean, and it says it's got a mean of 30 and standard deviation of 7. So that key point's 37, 44, maybe 51. So subtract 7 all the way along. 23, 16, 9. So once you've got that information, we can then go, okay, let's have a look at scores between 23 and 37. So 23 to 37 is within one standard deviation of either side. So probability of 23 is less than X, which is less than 37. One standard deviation, which is 0.68. Greater than 44 is that section there. Okay, so what does that mean? So let's have a think about that. So 44 is 2 standard deviations. So from 44 to 16 is 95%. Okay, so we know that that little section there is 2.5%. Not very good writing, sorry. 2.5%. Yeah, because 2 standard deviations is 95%. So 2.5%. So the probability that X is greater than or equal to, it doesn't matter whether it's greater than or equal to or greater than 0.025, which corresponds to that value up there. Less than 9 is 1, 2, 3 standard deviations. X is less than or equal to 9, so 3 standard deviations. Well, remember, 3 standard deviations covers 99.7. So that's 99.7. So we have 0.3 in the tail, so I've got 0.015 at the very end. 0.15 is actually 0.0015, isn't it? Sorry, didn't do my sums too well. 0.0015, so let's be clear about that. So we have 0.15% in the tails, divide by 100, gives me 2 zeros. So 0.0015. So let's just rub that out. Oops. Rub that out and let's get that right. 0.0015. 0.0015. Okay, Okay, so a diagram and things fall into place for us relatively nicely. Example 3, a normal distribution, mu70, standard deviation of 18. Again, first thing I'm going to do is draw a diagram. Put in the key values. There's 70 plus 18 is 88, 96, 106, 124. Subtract 18 for 52. Subtract 18 for 34. Subtract 18 for 16. Now, the range between which 68% of the values lie, that's one standard deviation. So it's going to be between probability that 52 is less than x, which is less than 80. The range of 95% is 2 standard deviations. So 2 standard deviations is 34 to 106. 34 is less than x, which is less than 106. See, I'm just changing the less than or less than or equal to. It's not relevant. The value for which 2.5% of all values are below. So 2.5% below is under the second standard deviation, isn't it? Because within 2 standard deviations is 95, so we've got 2.5 above it. So 2.5% is in the tail. So 2.5% is in both of those wings. And so we want to know, let's read that question carefully again, the value which has 2.5% of all values below it. So that's x is less than 34, isn't it? All right, off you go.